Hello friends, so this is the 8th question related to diode connected circuits which we are going to discuss. So here again we have this circuit. It consists of two diodes, silicon, they are silicon diodes, okay. Both are silicon diodes and they are connected in this way, in opposite manner, pointing or facing each other. The n-type ends are facing each other, and there is a 24 volt independent source and the 6.8 kilo ohm kind of a load resistor. So it has been asked to find this current flowing through the two diodes ID and this output voltage. So again, the behavior of this circuit, it depends on the behavior of the diodes, the state of the diodes. So the first thing which we have to do is to find the state of the diodes. So we will assume, let us assume that both the diodes are on. Let us assume both the diodes are on. So we will replace them by their equivalent built-in potentials. Here there has been no mention in the question about any forward resistance, so we will neglect that. Only we will replace them by their built-in potential, which is 0.7 volt for silicon, because it has been mentioned silicon. So let us redraw the circuit. Okay, P type end first, then N type end, 0.7 volt. Here the N type end first, then the P type end. This is also 0.7 volt, and then we have is the 6.8 kilo ohm resistor. Okay, this is V out. This is 0.7, this is 24 volt. This is the diode current, let's say. So when we apply KVL here, it will be 24 minus 0.7 plus 0.7 minus 6.8 ID is equal to 0. These two get cancelled out. That implies ID is equal to 24 by 6.8. Okay, so it is coming around, let's calculate, it's coming around 3.53 milliampere, kilo ohm. Okay, so it's milliampere, 3.53 milliampere. Now the interesting thing here is it is positive. So this current here, it is flowing like this, ID. This is D1, this is D2. So it is actually flowing like this. P, N, N, P. ID is flowing. For the first diode D1, it is flowing from P to N, no problem. So it means diode D1 is forward biased. But for the second diode D2, it is flowing from N to P. N to P. So it can never happen that in a forward biased diode, current can flow from N to P end. So diode D2 is reverse biased, which means it is open circuit. It is open circuit. Our assumption that both the diodes are on is wrong. It is open circuit. So when it becomes open circuit, it means ID is equal to 0 ampere. ID once is 0 ampere, it means V out, no current flows through this 6.8 kilo ohm resistor. So V out is also equal to 0 volt. ID is also 0 ampere or 0 milliampere, whatever, it's 0. Okay, so here this is the important thing. Even if there are two diodes, they are connected in opposite way. If they have been connected in the same manner, then both of them would have been forward biased, but they are connected in opposite way. So one is forward biased, but it becomes useless because no current will flow through the circuit, okay, because this second diode is open circuited. Okay, so this is the behavior of the circuit. So ID is 0 ampere, V out is 0 volt. Okay, so this is the 8th question that we have discussed related to diode connected circuits. Hello friends, so this is the 9th question that we are going to discuss related to diode connected circuits. So this circuit is a very interesting one. Why it is interesting? Because it consists of two different diodes. Okay, they are p-n junction diodes, but one is of silicon diode, and the other one is germanium. Then we have this 10 volt independent voltage source, then we have this load resistor 1 kilo ohm, and it has been asked to find this current I and the output voltage. Okay, so before we proceed, we know silicon has a built-in potential of 0.7 volt, germanium has a built-in potential of 0.3 volt. So if we see here, this 10 volt which is connected, it is connected to the p ends of both silicon and germanium, and 10 volt is sufficiently higher than both 0.7 volt and 0.3 volt. So I think the circuit behavior will be something like this. This will be the circuit behavior. 0.7 volt, 0.3 volt, both the diodes are on. They will be replaced by their equivalent built-in potential. This is 1 kilo ohm. This will be the circuit. Okay, yes, 10 volt is connected to the p ends of both the diodes. 10 volt is sufficiently higher than 0.7 volt and 0.3 volt, so easily both the diodes will be on, isn't it? But this is a mistake. It is wrong. Yes, it is wrong. Why? Because you see, this germanium has built-in potential of 0.3 volt, silicon has built-in potential of 0.7 volt. So what happens is that when it is connected to the circuit, germanium having a lower built-in potential than silicon will get turned on first, and this will maintain a constant 0.3 volt across this, as both the diodes are connected in parallel. So 0.3 volt will be maintained between these two terminals, and this silicon diode having a built-in potential of 0.7 volt will never get a chance to get turned on, because the same 0.3 volt is being maintained between these 2 points, let's say P1 and P2. Between these 2 points, as germanium diode gets turned on first because of its lower built-in potential, VP1 and VP2, they have a voltage of 0.3 volt always. So this germanium silicon diode will never get a chance to get turned on, so it will always remain in off mode. It will be open circuited. It will always be open circuited. So here the one diode having a lower built-in potential will get turned on first. It will not give a chance to the other diode to ever get forward biased or to be activated. So this is the actual circuit. This is correct. So now if we apply KVL in this circuit, so if we apply KVL, it will be 10 minus 0.3 minus 1 kilo ohm into I is equal to 0. That implies I is simply 9.7 milliampere, and V out is equal to 1 kilo ohm into I, which is 9.7 milliampere into 1 kilo ohm, which is 9.7 volt. Okay, so here the main concept was this: these two different diodes with different barrier potential or built-in potential being connected in parallel. The remaining was just simple mesh equations, writing KVL equations. That is different, but here the concept lies here: two diodes having different built-in potentials connected in parallel. So if you are a beginner into analog electronics, it is very much possible that you will commit this mistake. Assuming that both the diodes are on, you replace them by their built-in potential, which is very common. But actually this germanium diode having a very low, not very low, but having a lower built-in potential as compared to silicon will get turned on first. These two points will always be maintained at a potential of 0.3 volt, thereby not giving a chance to silicon to ever get activated because it has 0.7 volt barrier potential. So this is the actual circuit. Okay, and this we have got the results: I as 9.7 milliampere, V out as 9.7 volt. Okay, so this is the 9th question related to diode connected circuits which we have discussed. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.